Hi guys, this is Mr. Barlow. I'm tuning in to teach you a little bit about something called orthographic projection. So orthographic projection is a big part of our class in CAD Mechanical Design. It's a part of Strand 5 in the state standards. It's right here. So students will be able to develop something called orthographic views of a part with the correct dimensions and geometry. So there's a few different sections to this, but today we're just going to focus on the concept of what an orthographic view is and what that entails. So, in my own words, just really quick, an orthographic view is just the two-dimensional views of something in its top, front, right, left, bottom, and back views. Basically, if you put something in a cube, like a glass cube, and you turned it around in your hand, you look at it from the front, from the back, from the top, and you draw out what you see, the two-dimensional version of a three-dimensional thing. So, for example, for me, if you're looking at me, my front is my face, my right view would be this side, it would be kind of my profile, and then my left would be the profile reflected the other way, and then the top would just be like the top of my head like that. So, basically if you took a picture of each of those positions I just took, you'd see and drew an outline. That would be the orthographic projection. So to simplify it a little further, I've got this video here that explains it really well. Pay attention to how he uses these cubes that we have in class, the snap cubes, and he arranges them in different positions so you can see the top, front, and the right views.
An orthographic drawing is used to represent a three-dimensional object using several two-dimensional views. So how do you make an orthographic drawing? In this example, I'll be drawing a three-dimensional object made of blocks that snap together. To keep it simple, think of each block as a basic cube. Here's the example object. This is the front view, the right side, and this is the top view. Graph paper is helpful to draw the different views. From this perspective, here is the front of the object. It looks like this. For the front view, I'll draw 4 blocks up and the green block on the side. Next, I'll draw the right side view. It looks like this. It's the same height as the front view, so I can draw reference lines over. This can be done for any details that line up on different views. The right side is 4 blocks up, and 1 block over for the red bottom block. Lastly, I'll draw the top view. It looks like this. The top view is the same width as the front view, so I can draw reference lines up. This is the blue block, the green block, and the red block. And now the orthographic drawing is complete. Using this basic technique, even very complicated three-dimensional objects can be accurately represented.
Yeah, and he's right. So you can take some pretty complicated pieces, anything that's three-dimensional, and you can turn it into an orthographic projection. So for today, all we're going to talk about are cubes. We're just going to keep it pretty simple for you. In the future, we'll start using objects with curves, things with radiuses, radii, and chamfered surfaces, and more complicated geometry. But for today, we're just going to worry about this cube. So using that same cube, I went ahead and I modeled that same one he used in the video, and you can see using this cube over here where my mouse is on the right side of your screen, it's kind of circling there, that is our orientation box. You can kind of think of this as a glass cube, and you can say, if I click here, I can look at this from its front view. If I click on this side, I can see it from the right view, and then from the top, and so on. I can orient this kind of however I like. The home view gives us the 3D view, while all of these other orthographic views give us only the two-dimensional version of that object. So all of these views are really important when we're doing multi-view drawings. or orthographic projection. Both of those mean the same thing. Drawing here, I'm going to take that object and I'm going to place each of the flat surfaces, the flat views, the orthographic views, and orient them so that if I were to send this to another engineer or a manufacturer, he could look at it and could say, oh, this is the front view, this is the right, and this is the top, just based on where it's positioned on my paper. So we always start with the front view right here. So I'm going to drop this front view right here. I'm going to drag up and click my top view, drag to the right, and then that's going to produce my right view. So these three are all orthographic, top, front, and right. This last one that I'm going to include is actually a part of next week's or our lesson next time. This is called a isometric drawing or a 3D drawing. So an isometric has three axes, the x, y, and the z, or height, width, and depth, while orthographic only has two of those. This one only has height and width, this one only has height and depth, and this one only has depth and height. And then this one combines all three. So you click OK, and leave this right here. And some important things as well. These are not only is the orientation important, the alignment is essential as well. If I click on these, the computer program I'm using automatically recognizes, oh, these need to stay together to show that these planes are related. So that this surface here is related to this one to that, and so on. So all of these, no matter how I try and drag these, they stay in relation to another. I can drag and click one of these by itself, but I'm locked. I can only go up and down for this. I can't go any other direction. In this one I can go back and forth, but I can't go up and down. So that is kind of, that works nail anchor on the front view. The front view is sort of your anchor view for all of this. So that is orthographic projection in a nutshell. I hope this was enlightening, and I hope you have a great day. See you in class.